Now, as we are done with the creation of our vector store, we can move towards the next step, which is to create the user interface where user can enter his query, and using that query, we will retrieve the relevant document and then pass the relevant document with the query in a prompt to a large language model to generate the response. And the response which we will get from the large language model, we will show that to the user. So let's first create a new file, new Python file. So click on this plus, click on this Python file. Let's name it as a app. So to create the user interface, we are going to use Streamlit. It is a very easy to use library. So first install the Streamlit. So pip install Streamlit. It will install the Streamlit for you. So after the installation is done, go back to your app.py file and import Streamlit as st. Now to run this app.py file, go back to your terminal, type Streamlit, run, and the path of file which we want to run, client and app.py. It will run the app.py file for us. Go back to your Jupyter. Now let's first create a header, st.header, in which you will write asks me anything. So if you run this again, yeah, so now it's showing us the header. So the first thing which we need is to create a chat box where user can enter his query. So st.chat input, here we will also type ask me anything, and if we run this, we'll get the chat box where user can enter his query. Now we will store this query in a variable called user query. Now we will use this query to retrieve the relevant document from our vector store. So for that we have to first create our retrievers, and to create retrievers we need the embedding model. So let's first create our embedding model, or we can say let's first define our embedding model. So for that we will create a function and we'll name it as a load embedding model. So when we invoke this load embedding model, it will return us the embedding model. So let's first define our embedding model here. We don't need to define, we can just copy from vector formation. So copy this one. Also import the library. And we have to return the embedding model here. Now we have the embedding model. We can define our retrievers. So in our case, we are using multiple retrievers. So before defining our retrievers, let's first look how our overall retrieval process will look like. So we have a query which user entered, and using an embedding model, we are first converting that query into an embedding query, meaning we are converting that query into a vector form so that we can use retrievers with a search type of MMR and search type of cosine similarity to retrieve the relevant documents from our vector store. So after converting that query into embedding query, we are passing that embedding query to our retrievers. Here we are using two retrievers. One retriever is uses search type of MMR, maximal marginal relevance, and another retriever uses search type of cosine similarity. So in cosine similarity, it's check cosine angle between two vectors to check how close they are, meaning how relevant they are to each other. And in maximal marginal relevance, it returns the most relevant documents by preventing redundant data. So after getting relevant document from both of the retrievers, we are using an ensemble retriever to ensemble the result which we are getting from both of the retrievers. So after ensembling the result which we are getting from both of the retrievers, we are reordering them. So in this step, it will reorder the document based on their relevancy. It will shift the more relevant document either at the beginning or at the ending of the context. So after that, we are passing the context to a prompt along with the query to a large language model to generate the response. Now let's implement our retrievers. So we are using two retrievers. So let's create two functions, def load retriever1, and there will be another function which is for the second retriever. So let's name it as a load retriever 2. So let's first define our retriever 1. So the first thing which we need for retriever is the embedding model. So let's call our embedding function here. Now to use this embedding model in our vector store so that we can use vector store as a retriever, let's define our vector store, which we can define using chroma. In this, we have to provide two parameters. First one is persist directory, where we are providing the path of our vector store. So the path is vector dv. And the second thing which we have to provide is the embedding model. So embedding model. Now we want to use this vector store as a retriever. So retriever vector store as retriever. In this, the first retriever which we want to is will use MMR, maximal marginal relevance. So search type will be MMR, and there will be one additional parameter which we will provide, which is search quarks. So what it will do, the search quarks parameter, it will return only the top k relevant documents. So in our case, we are using 6 as k, so it will return top 6 relevant document. Now we will return this retriever. And similarly, we have to define for retriever 2. So we can just copy this code. The only thing which we have to change is this. Here, rather than using MMR, we are using cosine similarity. So just type similarity. Now we have to ensemble both of this retriever So let's create another function in which we will name it as a load final retriever. Now when we invoke this load final retriever, it will return as the final retriever. So inside this function, let's first call retriever1 and retriever2. So retriever1, in this we will call load retriever1, and in retriever2 we will call this load retriever2. Now we got both the retrievers. Now the next thing which we have to do is to ensemble the result which we are getting from both the retrievers. So yeah, also we have to import this chroma because we are using here. So from LangChain community dot vector store, we have to import chroma. Now to use the ensemble retriever, let's first go to the LangChain official documentation. So search LangChain ensemble retriever. Click on this first link. In this, we have the document for how to combine result from multiple retriever. So in this case, we can use the ensemble retriever, which uses reciprocal rank fusion algorithm to ensemble the result from multiple retrievers. So you can check this out. You can check this reciprocal rank fusion algorithm by visiting their official documentation. So now to use the ensemble retriever, we have to first import this retriever from langchain.retrievers, and inside this ensemble retriever, there are two parameters which we have to pass. First one is retrievers, the retrievers which we want to use, and the weights which will be assigned to each retriever. So let's call this function also. So the first retriever is retriever1 and the second retriever is retriever2. Let's leave the weight as it is. Now we ensemble the result which we are getting from both the retrievers. Now we can reorder the documents based on their relevancy. We are going to use long context reorder. So let's search that also. So LangChain long context reorder. So click on this first result. So this page is about how to reorder retrieved results to mitigate the loss in the middle effect. So to do that, we are going to use long context reorder. It is a document transformer. So by using this, we can reorder the document where the less relevant document will be at the middle of the list and more relevant element will be at the beginning and end of the context. So let's use this. So from LangChain community.document transformer, we can import this long context reorder, and to use this, we have to first define it. Now, because we are going to use this reordering dynamically based on our query, so for that we have to use another function called contextual compression retriever. So let's search that also. LangChain contextual compressor LangChain contextual compression retrieval. So if you click on this first link, this page is about how to retrieve with contextual compression. Now to use this contextual compression, we will need two things, a base retriever and a document compressor. So for base retriever, we have this ensemble retriever, and for compressor, for document compressor, we are going to use this long context reorder document transformer inside a pipeline, inside a document compressor pipeline to use as a document compressor in contextual compression. So let's first see how to define this contextual compression. So to use this contextual compression retriever, we have to import this from langchain.retrievers. So let's first copy this, and inside this contextual compression retriever, we have to define two things, base compressor and the base retriever. So let's just copy this. So in base retriever, we are using this ensemble retriever, and for base compressor, we have to further define another thing, which is a document compressor pipeline here. So here we have a document compressor pipeline which we can use to easily combine multiple compressor in a sequence. So how to use this document compressor pipeline? In this we have to import this from langchain.retrievers.document compressor, and to use this we have to define transformer. So for transformer, in our case we are using long context reorder. So just copy this one, and let's define this. So pipeline compressor, document compressor, inside this we have to define the transformer. So for transformer we are using this long context reorder, and then we will use this pipeline compressor in our base compressor, and after this we will just return this compression retriever.